Hey engineers, this is Mr. Hernandez, and today we're going to be talking about a specific piece of programming terminology, something that you guys have actually used in your programs before, but now we're going to be using it a little bit more deliberately. So what we're talking about today is something called a variable. So in programming, a variable is kind of like a box that we can use to store information. This box, it needs a couple of things. So it's going to need to have a name, that way we can use that variable and we can call that variable later in our program. And it also needs to have a value, whatever that variable is storing. And that value can be a lot of things. That value can be a number, it can be letters, it can be words. And in programming, there's something we'll get into a little bit more specifically later on, but there's something called a Boolean. I know it's kind of an odd term, but that basically is high or low. We'll deal with Booleans a lot more a little bit later on. For right now, let's look at a quick example of how we're going to use variables and how this actually works. Alright engineers, so now we're going to look at an example of one benefit that variables can give us. So I've got this program right here and I want to use it to make an LED blink. So like always, we set the LED to high, we're going to wait a certain amount of time, then we set the LED to low, and then we wait a certain amount of time again, and then the whole thing loops to the beginning. And that's how it blinks, on, off. So let's say I have a delay of 5 seconds, and I have that same delay down here. And if you remember, larger numbers for the duration of the wait block, those are going to make the LED blink slower. So let's say I have this and I decide I want to make this blink faster. Well, now I have to go in and I have to change both of these. So I have to go from 5, let's say we want to speed it up to 1 second delays. Pretty big jump there. Now it's not such a big deal when we just have 2 blocks, but we've written programs that have more than that. And so that becomes a little bit tedious to have to change all of them. So let's look at this same program, but with variables instead. Alright engineers, so now we're going to look at an example of one benefit that variables can give us. So I've got this program right here and I want to use it to make an LED blink. So like always, we set the LED to high, we're going to wait a certain amount of time, then we set the LED to low, and then we wait a certain amount of time again, and then the whole thing loops to the beginning. And that's how it blinks, on, off. So let's say I have a delay of 5 seconds, and I have that same delay down here. And if you remember, larger numbers for the duration of the wait block, those are going to make the LED blink slower. So let's say I have this and I decide I want to make this blink faster. Well, now I have to go in and I have to change both of these. So I have to go from 5, let's say we want to speed it up to 1 second delays. Pretty big jump there. Now it's not such a big deal when we just have 2 blocks, but we've written programs that have more than that. And so that becomes a little bit tedious to have to change all of them. So let's look at this same program, but with variables instead. I'm going to have a block up here at the top that's going to be setting the value of our delay variable. So the name of this variable is delay, and I'm setting its value to 5. So that means that whatever you see delay, what that really means is 5. Okay? And I'm going to use this to control how fast this blinks. Because if you remember, the length of time that we have on our wait blocks, that decides how fast our program runs, and that decides how fast our LEDs blink. So what we can do here is just use that same variable down here. So what this means is we set our delay to 5, set the value of our variable, And now, when we come to our program, we're going to turn the LED on, wait 5 seconds, turn the LED off, and wait 5 seconds. All right, so that's all pretty straightforward. So now let's look at that same issue. Let's say we realize that 5 seconds is way too long. So we go ahead and change from 5 to 1. Which changes the value of our delay variable. But it doesn't just change it up here, it changes it everywhere that we have the delay variable. So by making that one change to that one block, we update that variable everywhere that we have it. All right, engineers, so now let's take a look at a little bit more details of how exactly we're going to use this and our first program where you guys are purposely setting your own variables. So from here, let's go ahead and take a look at why we would use variables in a program. So we know that variables let us save information in a program, and in that program, it can either be static, like we just saw in the last example, or we can update it in the program. So by static, I mean we set the value of the variable right at the beginning, and we use it, but we don't change it throughout the program. Updated means that as the program runs, we actually adjust the variable on the fly. So one example of a static variable would be in a game, your maximum health is going to be stored as something that's usually pretty static because it doesn't change very often, and you want to keep track of what that maximum is. That way you can't go above it. In contrast, a variable or a updated variable would be your current HP. Because as you go through the game, as you bump into things and take damage, you're constantly going to be adjusting it, bringing it down for damage, bringing it up for healing, and so on. So those are two ways that, at least in video games, we would be using variables. Let's keep going and let's look at the specifics of how Tinkercad treats variables. This week, you guys are actually going to be creating your own variables in Tinkercad, and that's a 3-step process with the way that Tinkercad has it set up. And that's actually going to be different in some other programs. They all sort of treat variables a slightly different way, but in Tinkercad, we have to create the variable first, and then we can use it. So let's look at how we create that variable. So step 1, we need to go to this section. So we're going to go to blocks, switch to the variable section, and then click on create variable. That's going to give you a pop-up that I'll show you later on, where you actually type in the name of that variable. Now, after you type in that name, right below this, your new variable blocks are going to show up. So if I create a variable called button state and another one called loops, those are going to show up under my variables blocks. After we have that variable created, see this little round section with its name on it? Then we can plug that straight into other blocks. So this variable that we created is now being plugged in, and we're using it to check if we've pressed a button. That's just one example. So that's how you create a variable. That's how you use a variable directly. So now let's look at how you set the value of a variable. So there's another block that looks like this. It says set variable name to variable value. So from left to right here, we can read this as set button state to 0. So this is how you just tell Tinkercad this variable has this value. This is what we're putting inside this particular box, in other words. And now let's move on to how else we can interact with these. So these are two common uses of a variable. A lot of the times we don't want to just set a variable to a number, because oftentimes we can just plug in that number directly to where it needs to go, unless we're going to be using it a lot, like in my blinking LED example. So on the left side here, we can see an example where it doesn't just say set button state to a number, it says set button state to read digital pin 2. So here we are storing a value from a sensor on a pin. That means that we're checking what's on that pin, and then we're storing it here, and then we can save that and use it for other things later in the program. This is how we can write programs that do different things depending on if you've pressed a button or not. Now on the right side here, we can see something a little bit different. This one doesn't say set variable. This one says change variable. So this one is going to increment the value. What that means is it's going to be adding on to it. So let's say the value of loops is 0 right now. Well, if we have this block in our program and the loop goes through once, well, we incremented loops by 1. That means that we're adding 1 to the variable loops. We come back through the top, and then we increment it again, which means that we add 1 more to it, and now the value of loops is 2. So this is a way that we could keep track of the number of times that a program has actually looped around, which can be useful sometimes. All right, engineers, so now let's go jump into Tinkercad and we'll look at the circuit and the program that you guys are building today. So from here, let's get into the circuit template that I'm going to be providing to you. So there are a couple of things that I just want to point out here. So in this circuit, we don't have any buttons. Instead, we have these 3 LEDs, and these LEDs should be wired to pins 3, 4, and 5. These are what we're going to be using to demonstrate our code today. Now, because I'm giving you guys this template, and I'm even giving you guys the code to start off with, there are going to be some things that are incomplete on your version. So make sure that the circuit is complete before you move on to the code. Just make sure that everything works before you start coding. There's a few things that I'm going to change, things that I might remove between this version and the version that you guys actually get. Just a heads up there. Let's go ahead and take a look at the code. So at the beginning, the LED should be set up to just blink each of the lights in sequence. And you can see in the program that we've got here, we've got pin 3 turning on and off, then pin 4 turning on and off, then pin 5 turning on and off. And we know from past experience what that's going to do. It's going to make the LEDs blink on and off in sequence. You want to always test things out to see if it has the correct behavior. I've seen a lot of mistakes in students' code so far, where if you just ran the simulation, it would be very easy to catch that it's not doing things correctly. So from here, we're going to rewrite this program, but with a variable. Actually, right before that, let's take a look at why we want to do that. If I want to change the timing here, like I was explaining before, I have to change every single wait block. And there are quite a few of them, even just for this simple program. And not just that, if I want to change all of them, there's always a chance that I'm going to miss one. I'm going to type one in wrong, and then it's just going to mess up the program. So something that, using a variable for this situation does is it removes that one chance of error. As far as variables, so like I showed you in the presentation, you're going to go over here to the variable section and you're going to click on create variable. Important difference here. I want to make sure that you guys are doing the work on your own. So the variable you need to create is different from the variable that I'm going to create right now. I'm going to create a variable named delay. You need to create a variable named time. Okay? So keep track of that. Make sure you're creating the right one. Now, when I create that variable, you see the variable blocks come into existence right here. It doesn't create the variable blocks in Tinkercad until you actually have a variable to use it with. So in this case, I just need to add 2 things here. So first, I need to drag delay out to the very top. So this is the set delay block. I'm going to set this to 1000. And then I need to take this circular part and I'm going to put this into all of the wait blocks. So that substitutes the delay variable into every single one of them. Now you might have noticed that all of the wait blocks are set to milliseconds. This is getting into something a little bit deeper in programming that I want to cover right now. But basically, the variables that we're using right now can't store decimals. So if I want to be able to set anything less than 1 second, I have to change this to milliseconds. And the conversion ratio is really simple. It's just 1000 milliseconds equals 1 second. So right now I'm setting all of these to 1 second. So let's take a look. And it looks like we're back to that same behavior at the beginning. This is a slow blink. And if I want to change the timing, let's say I want to go much faster, I could just change this one number up here. And it's going faster. And you can see it's consistent as well. No chance of making mistakes somewhere down here. And if I want to just keep on dialing something in, let's say I'm going for a very specific timing, I can just keep testing numbers out just one at a time like that. Okay, engineers, so that wraps up the explanation here. Keep in mind you should just read the assignment instructions very carefully. Because I'm only going to have you guys make one program here, I am being very specific here. So read it carefully, make sure you have everything set up right, but the variable name and value, and you don't mess anything else up in the program. All right, engineers, I know this is a long video, but this is going to wrap it up here, and then you can go ahead and complete your assignment.